Alright, Chapter 12, Electricity, Magnetism, Frederick F. Discroll. Introduction. Chapter reviews basic concepts in electronics. It's divided into 10 sections listed below. Current, voltage, power, resistance, direct current, circuit analysis, inductance, capacity, resistor capacity, resistant inductor circuits or RCRL circuits, and alternating currents, AC circuit analysis, operational amplifiers, electromagnetic fields, DC motors. And then summary. So, chapter 12:1, current, voltage, and power. On physical world, the interpreter of the terms of the matter, energy, both exist in variety of forms. Matter undergoes changes energy either for the cause or result of the change. Matter has been defined anything that occupies space or that possesses mass. Energy, on the other hand, is the ability to do work. Although energy itself cannot be measured, results can. Matter exists either by solid, liquid, or gaseous state. Since most electric components are made of solids, circuit analysis usually begins with introduction to atomic structure, the least of the properties of the electronic charge. Electric charge, one's unique property to the atom, an electron with a negative electrical charge. Charge signal with electron, smallest electrical charge that exists. The purpose of the analysis of the particular group with a large number of electron charge. Hence, for the basic quantity of the electron charge is a coulomb. 1 over the coulomb equals accumulated charge to 6.24 to the 10 to the 18th electrons, represented as a lowercase q or a capital Q. It is conventional lowercase letters are the representative values variety of the time, and use uppercase letters represent values that do not vary within time. Changes charges value flows easily through conductors. Material of the good conductor, electrical conductors composed of the atoms only one valency electron. With the valencies of the electrons are the electrons in the atoms are most energy level. In a metal, valency of the electrons are not tightly bound with the nucleus of the atom and said to be free or mobile. Good conductors such as silver, copper, and aluminum have higher concentrations of free electrons. Materials such as air, glass, mica, rubber have considerably fewer free electrons and referred to as insulators. Current. To understand electrical current, consider the portion of the conductor shown in Figure 12.1a. First, consider the case with no outside energy except the thermal energy is applied with the conductor. Thermal energy is always present with the used. Because the temperature of the absolute zero cannot be achieved under normal conditions, the free electrons are said to be uniformly distributed with the randomly motioned. Free electrons are uniformly distributed to have the random motion. With the material uniform distribution means free electrons will not be concentrated with one particular location, permeate through the material or gas, diffuses through the gas closed container. Thus, any instant incremental value of the same size will contain the same number of free electrons. Random motion means that no specific direction can be assigned for free electrons. Therefore, the probability of finding a particular number of the free electrons moving in one direction is the same as finding an equal number of the free electrons moving in the opposite direction. Thus, the net motion of the one direction is zero. The free electrons in it have the direction energy other than thermal energy must be applied to one end of the conductor. The positive charge is connected to one end of the conductor, the negative charge to the other. The potential difference is created with the end of the conductor as shown in Figure 12.1b. Since like charges repel, and shown in Figure like charges repel, unlike charges attract, electrons can travel toward the positive end of the conductor and away from the negative end. Even with the application, different charges of the conductor have caused the free electron to move toward the positive charge, but do not move in the straight path. Instead of the follow the zigzag pattern similar to the random motion, unlike of the true random of the motion, however, the no finite drift toward the positive charge. Net motion of free electrons one direction constitutes an electronic current known as a drift current. The current depends on the rate at which the free electrons move. The term rate implies the quantity divided by the time. It should be noted. Current, the rate of flow, will determine not the velocity of the term, and the current depends on the node of the speed of the individual electrons rather than the net motion of the larger number of free electrons. Unit of current is amperes, or A, which equivalent is 1 coulomb per second. Basic unit current amperes is of the definition amperes is of the 1 coulomb of the charge per cross-sectional area of the conductor, or in 1 second. This 1 ampere current, 1 ampere is equal to 1 coulomb over 1 second. The relation to be expressed as follows. Current of the time rate of charge is equal to the units of amperes. Time instantaneous charge is equal to dqt, or change of charge with respect to the time in the coulombs per second. Electron negative charge of the drift away from the negative terminal positive one. The principle of known of the electron flow of the analysis of the electron circuit that usually based out of the direction of the current with the energy source of the positive terminal through circuit the source of the negative terminal with the known as the conventional current direction. voltage. For any electronic current to exist, the conductor of the end of the conductor must be connected different charges with one of them possible to have at the moment of the free electrons, so that given the potential of the difference that exists between the 2 points of the circuit, whenever the one point with the positive charge and the other point with the potential difference for the cause of the current. The voltage potential is referred to either the potential rise or the potential fall. Voltage rise or the potential rise occurs when the work is done on a charge and in an element. Example of the energy source. The voltage drop and the potential fall exists when the work is done by the charge with an element, and the example is load. The distinction between the potential rise and potential fall is established by polarity making across all elements, figure 12.2. Electrical circuits consist of source, loads, and by conductors. Basic unit of the voltage potential rise with the potential fall. Voltage, the definition of volt, is also 1 joule of energy expended for moving a 1 coulomb charge from one point to another electrical circuit. Voltage is 1. Voltage is the measure of the energy transfer per unit which of the charge moved at 1 point to the 1 second in the circuit. 1 volt is equal to 1 joule over the 1 coulomb. Mathematical expression for the voltage is instantaneous voltage is equal to dW over dQ, the change of the energy respect to change in charge. Power. The goal of the electrical circuit is to transfer the energy from one point to another in order to accomplish useful work. Hence, the electrical circuit is composed of one and source of the two loads. The source supplies the electrical energy while the load converts the energy into the work accomplished. The circuit of the system has been designed with the rate of the energy transfer of the source of the load. Its power. The power is defined with the energy per unit with the basic unit per watt. Power is the rate at which energy is transferred. 1 watt is equal to 1 joule over 1 second. Although the power is defined with the transfer of 1 joule of the electronic energy, 1 second with the determinant with the measure value of the voltage current, with the power is equal to the voltage plus times the current. Using symbol the voltage, the current gives the expression P is equal to VI. Summary of symbol of the expression of the charge, current, voltage, energy, power is summarized in table 12.1. Summary of the basic electrical quantities. The quantity of charge is the Q, the distant coulomb, current is an I in amperes, voltage is V in voltage, energy is W in watts, and P is power in watts. Electrical circuit. The section summarized with the main concept of the analyze of the electrical circuit consists of the energy source, the load with the energy source with the primary voltage source with the loads with the contained with the passive components active with the devices along with the passive components. The passive components will capable only with the strong with the dissipating energy with the resistance. Inductancy, self-mutual with the capacity of the resistance converts electrical energy into another energy form. Self-inductance stores energy with the magnetic field with the mutual inductance transfer of the energy from the one part of the circuit to another through the magnetic field. Capacity stores energy in the electrical field. Operational amplifiers introduced in section 12.8 are one of the type of active devices used to design with electrical circuit. These review concentrate primarily, however, the passive circuits. 12.2. Resistance previously mentioned with the application of the potential energy of the conductor caused the net movement of the free electron with one direction. For under the influence of the potential energy of the path, the single electron is not straight but a zigzag pattern, similar to the random motion. One of the cases of the zigzag pattern of collision of the electron with another atom, since energy cannot be destroyed but externally applied with the potential energy of the transform by the kinetic energy of the electron. Electron collides with the atom and heat with the produce of the thermodynamic process called the Joule heating. Collision simultaneously produces the heat constituted with the opposition of the flow of the current. The opposition of the flow of the current is resistance, shown in figure 12.3a, with the circuit analysis of the primary characteristic resistance for the energy conversion, dissipation of heat, with the other forms of energy. Every material used with the conductor has similar with the degree of the resistance. From the material conducted electricity charged with more efficiency than is less resistant. Products with heat with the others with the copper, for example, the excellent conductor, where steel is a good conductor but not an excellent one. Resistance is the characteristic of the part of the device that transforms electrical energy into heat. Resistance is designated with the letter R, capital R, with a symbol shown in figure 12.30b and 12.3c. Basic unit resistance is ohms, and that shows the symbol of the resistor, same letter and the same designation, is the actual physical device that is inserted in the circuit system. Limited flow of the current that produce the voltage drop that dissipate the energy. Resistor may be classified either the fixed or variable. The fixed resistor is one whose voltage value is constant, while the variable resistor is one whose value may be changed with the circuit. The change with the fixed of the variable resistor is shown in figure 12.30 and 12c, respectively. The resistor material with a uniform cross section is given in the equation. Resistance of the material with a directly proportional resistance of the length of the inverse proportional to the cross sectional area. So we have resistance equal to the resistivity times the length of the material over the cross-sectional area with the units measured with the indicated with the parentheses with the equation is illustrated in figure 12.3a with the typical values resistive of the various materials are table 12.2 silver, copper, aluminum, and insulators. Resistive material that depends on the temperature for the most type of the resistivity increase and increase the temperature for the equation 12.5 and 12.6. We choose resistivity in ohms and meters to resistivity, resistivity and resistance are relative values respective of the temperature 0 and acceleration of the temperature coefficients of the resistance of the units of the acceleration are 1 degree of Celsius. Ohm's law of linear resistor voltage drops coupled with the resistor directional proportional with the current given to the ohm of the voltage coupled with the resistor directly proportional with the current through the resistor voltage T is equal to the amperage for the time of the resistance. The current voltage do not vary with the time. Ohm's law was usually written as voltage is equal to amps times the resistance. Power dissipated with the resistor, power dissipated with the resistor determined by the E with the equation power is equal to voltage time of the amps equal to voltage squared over the resistance or equal to amp squared time of the resistance unit of the power watt in joules and per second. Resistors in series, resistors connected in series have the same current through each element as shown in figure 12.4 with the sum of the voltage across the resistors equal to the source of the voltage relationship known as Kirchhoff's voltage law. Voltage total is equal to volts 1, 2, 3, and applying Ohm laws, each law to the resistor yield voltage total is equal to 1 resistor 1 amp resistor 1 amp resistance 1 amp resistance 2 amp resistance 3. Voltage total voltage is equal to amps times the resistance 1 plus resistance 2 plus resistance 3. Total resistance seen by the source is resistance 2. Resistance total is equal to resistance 1, 2, and plus 3. Elements in the series have the same value with the current through the elements in the circuit shown with the N resistors in series. The total resistance of the R was R1 plus Rn to the R to the nth. Resistors in parallel. Two or more resistors are in parallel. They experience the same voltage drop of the chapter figure 12.5 with the show of the three resistors parallel with the shift off the current loss state with the sum of the currents in the node equals sum of the circuits with sum of the current leaving the node. Therefore, the circuit is known as amperes total equal to amps 1 plus amp 2 plus amp 3. Elements in the parallel have the same value with the voltage across them, figure 12.5 and 12.6. Since the voltage across each of the resistor are the same in the equation in 12.4, it can be divided in voltage total with this amperage voltage total equal to voltage total 1 over the resistor resistance 1 times voltage total over the resistor 2 times voltage total voltage total plus over the resistance 1 plus voltage 2 over the resistance 2 plus voltage total over resistance 3, or amps total times amps total equals voltage total of 1 over the resistance 1 plus 1 over the resistance 2 plus 1 over the resistance 3. Or each of the term the reciprocal Ohm's law and the rearranging of the yields equivalent in the resistance may be expanded. But there's only two resistors in the parallel. The equivalent resistance can be determined with the product over the sum rule. Resistance total is equal to resistance 1 plus resistance 1 times resistor 2 over resistance 1 plus resistance 2. The open circuit voltage is V to TH, or is V to TH, open circuit. The short circuit its current is amps to N. Norton equivalent circuits and equivalent circuits. Note, the product over the sum of the rule, only two with the resistor parallel, but can be used with more than once. For example, these three resistors connected with the parallel with the product over the sum of the rule will apply with the define with equivalent resistance for the first two with the resistor of the answer. You with the third resistor with the product over the sum of the rule applied again. The Thuvity and Norton equivalent circuit. Thuvity and circuit. So the two terminals of the circuit the representative of the series of the combination voltage over the resistor with the value of the equivalent voltage source of the voltage appearing with the open circuit terminals. Value with equivalent resistance equal to the resistance of the machine with the looking back with the network with all the energy source will play with the internal resistance ideal voltage source with the have with the zero internal resistance ideal current source have with the infinite internal resistance. Series combination voltage sources voltage source or which would be open circuit and resistor of resistor open circuit voltage open circuit and resistor open circuit known as the Thevenin equivalent circuit that's shown with figure 12.6. Sorry. Note the equivalent exists only with the terminals of the 12.7 is the application. Alternatively, the EVD equation of the resistance equal to the open circuit voltage and divided by the short circuit voltage. Norton circuit with a two-terminal circuit with a representative of the pair-wall combination current source of the resistor value with equivalent current source of the short circuit the current occurring and the terminal value with the equivalent resistance equal to the resistance seeking looking back into the network with all the energy sources replaced by internal resistance and ideal voltage source of the zero internal resistance ideal and ideal current source of the infinite internal resistance. The pair-wall combination current source is a short circuit in a resistor short circuit known as Norton's equivalent circuit is shown with amperage short circuit and a resistor short circuit known as Norton's equivalent circuit shown in figure 12.7a and 12.7b show with equivalent circuits. Example A, samples, solutions. Alright, the total current, the ampere total current is 12.3, the direct current circuit analysis. Section applies Ohm law with the Kirchhoff, the voltage of the current laws to solve the current and the voltage of the DC resistive of the circuit with more than one energy source. Some circuits they have with more voltage with one method to solve these problems assume with the Kirchhoff voltage law. Right set of simultaneously linear equations, unknown value with the loop currents, the rules of the writing set of the equations as follows. Thank you. 1. Determine the number of the loop's current using the expression of the T total over the number, where T is the total number of elements in the circle, and is the number of the nodes plus 1. Assign loop current with the independent closed path that apply with the Kirchhoff voltage law to each loop that you're applying with the Kirchhoff voltage to one with the loop of the element into more loop with the currents for the flowing through of the total voltage drop off the equal elements equal the sum of the difference of the voltage drop of the individual loop of the currents with a reference to circuit shown in figure 12.13a with the 3 steps are solved. The one circuit has 6 elements with the 4 nodes, therefore to analyze the 3 loop circuit is with amp 1, amp 2, amp A, amp B, amp C. Set loop currents as shown in figure Kirchhoff the voltage applied to each loop. Now you have 3 simultaneous equations that are unknown, but the direction of the loop may be either clockwise, counterclockwise, or one shown choice is made. Do not change it while you are solving the problem. Alright, 12.4. Inductance. The second and passive of the elements, as mentioned in section 12.1, but the conductivity, the unique property of the element of the energy of the magnetic field, let us examine some of the fundamental properties of the magnetic field. Figure 8.19. Electricity, magnetism, some of the contributed independent natural phenomena have over the years of the Hans Christian Oersted in 1777 and 1851 observed the interaction between electricity and magnetism. The new science of electromagnetism was bored Austrium. The experiment shows that the electron current caused magnetic compass needle to move because of the wire through the electron current flowed did not come into direct contact with the compass needle. The overstep of the concluded with the interaction must involve surrounding space. And whenever there is interaction between the 2 points of the space, the visible contact between them, the surrounding space is called field of the 2. The important property of the field with the intensity, the magnitude of the direction of the Oersted experiment with the current had an effect of the magnetism compass because of the field. We know that wherever the current flows over the conductor of the magnetic field, the greater the field of the current, the direction of both the intensity of the direction, magnetic field of the larger current value with the greater of the intensity, H, the magnetic field in which the vector quantity of the direction of the magnetic field is determined with the right-hand rule. If the thumb of the right-hand point with the direction of the conventional current with the finger of the right hand will circle around the conductor of the direction magnetic field. Because of the human trait to want to visualize that every concept is convenient in some way with the depicting of the field with the Michael Faraday in 1791 to 1867 one. A pioneer in scientific electromagnetism suggested adopting the lines of force representing the magnitude of the field. But although these lines are imaginary, the best way to visualize the magnetic, the further carrying current conductor figure 12.5a, some of the magnetic lines of force in their direction, with the direction magnetic field always perpendicular to the direction of the current field, but must always be the complete loop. Current carrying conductor wound with the form of the coil, not only with the magnetic lines formed in a circle with the infinitesimal portion over the conductor, but all those will be the edge of the magnetic field surrounding the entire coil. Up to the point of discussion and interaction between electrical and magnetism, have dealt with the fact of the flow of the current of the conductor that produced the magnetic field about the conductor. Now consider another interaction about the electrical magnetism and change the magnetic field of the surrounding of the conductor and induce the voltage within the conductor. This induced voltage is called the self-induced voltage because it is induced in the same conductor thus is carrying the current. Now the voltage, not a current, induces the conductor. The existence of the current depends on whether there's not either complete whether or not there's a complete circuit. If the induced voltage occurs with another conductor, the principle known as the mutual inductancy and an application of the mutual inductancy given in section 12.7. Ideal transformers. If the circuit is complete with the continuous path of the current with the direction of the self-induced voltage of the given in Lenz's law with the direction of the self-induced voltage is such for the opposite, such to oppose the change of the current. For example, some of the currents of the coil tend with the increase of the magnetic field of the bout of the coil with the increase of the direction of the self-induced voltage according to Lenz's law. In such case, such to oppose any of the change of the exhibiting and inhibiting and increase. The unit of the inductancy is in Henry. On the other hand, while the current in circuit with the decrease of the magnetic field, they also decrease the direction of the self-induced voltage tend to keep the current from decreasing when the magnetic field collapsing when it gives back energy back to the circuit with the temporary acting with the energy source of the opposition changing from the current and effect electromagnetic induction. Circuit element of the property opposing the change of the current with the circuit absorbing the energy magnetic field of the self-induces for the base of the inducing and multiple mutual and self of the Henry of the name it is the honor of the Joseph Henry of the induction electrical property storing energy magnetic field represented in the symbol L. Inductors store energy in a magnetic field. The inductor physical device connected with the circuit with the store energy of the magnetic field with the inductor that must be classified with the fixed or variable the circuit shown. Symbol of most type that's shown in figure 12.15. See with the fixed inductor must be adjustable value with either with the air core or the iron core. The variable inductor has an iron core that can be moved with the coil with the vary with the magnetic field, thereby with the varied by the inductance. Inductor storage energy with the magnetic field with the term of the physical parameters inductance is calculated using the following equation. Inductance is equal to permeability of the magnet metamaterial times air cross-section over the path and meter squared times the number of turns of coils over length over the path. Value of the permeability various parameter materials are listed in table 12.3. Air, iron, steel, permeability. Voltage current relation for any inductor voltage across the inductor depends on the value of the inductor and time of the rate of the change of the current through the inductor. The equation. So we have voltage inductancy with time of the time of the inductancy. DI inductancy. The inductancy in the amps length over the inductancy in time. Energy stored in an inductor. Energy stored in an inductor is given by the expression energy is half the conductor energy half the inductancy times the amperage squared. Inductor series total inductancy is equal to L1 L2 to the plus to the Lnth. Inductor series with the parallel will combine use the same rules with the resistor. Inductors parallel the inductor's current parallel combine the same with the resistors as parallel. Inductors in parallel is equal to 1 over the 1 to the L plus 1 to L to 1 plus 1 to the nth. And on two conductors, a conductor in parallel periodic surface, the same rule in L. The inductor's equation is equal to inductor 1 and inductor 2 over inductor 1 plus inductor 2. And then it goes into examples and figures, solutions. Alright, 12.5, capacitancy. Third passive element shown. Third is a third passive element mentioned in chapter 12.1 with the capacity property unique. These are the resistance and inductancy, wherever the difference of the change charge in circuit the voltage potential. The difference exists with capacitor storage energy in an electrical field, which is the space between the positive and the negative charge, as in the case of the magnetic positive charge of the one plate with a balance with the negative charge on the other plate. The field of the line of force of the concept that you may use the visual of the electrical field, unlike the lines of force of the magnetic field, which form the closed loop. The lines of the force of the electrical field always begins at the end down with the charges. Like the line of force of the magnetic field, the line of the force of the electrical field indicate both the strength of the directional electrical field intensity E. Vector quantity with the greater number of the line of the more intensity of the electrical field, the strength of the electrical field, the measure of the point of charge of the directly proportional with the charge of the indirectly proportional to the distance squared with the strength of the electrical field greatest closer to the charge of the degree that one moves away from that the direction of the electrical field with the path of the positive charge of the travel of the place in the field. Basic phenomenon of the charge, the likely charge of the repel with the unlike charges that travel the direction of the line of the force always with the positive charge with the negative charge is shown in figure 12.9a. With the electric field can be created a circuit placing the two conducting plate with the parallel having the one more positive than the other. Figure 12.9a. Material between the two plates with the non-conducting insulated with the insulating material is called the dielectric. With some of the dielectric common with the air bakelite, ceramic formica, glass, craft, poly polyethylene Teflon. This capacity with the property storing the energy of the electric field. Energy is stored between the parallel plates of the capacitor, which are the physical device with the property of the capacity. Use of the capacitance of farad. Capacitance of parallel plates such as these shown in figure 12.9b give the equation. C is the capacitance in farad equals the dielectrical constant of the area of each plate over the distance between the plates. The dielectrical constant. Several methods are listed in table 12.4. Dielectrical content: 6 materials: air, pyrex, mica, millet, mylar, quartz, titanium dioxide. To extent how one plate, the capacitor with the made with respect to the other plate with the consider the capacitor with the connect with the battery through with the switch is closed with the electrons from the negative terminal of the battery collected on the bottom of the plate to maintain equilibrium. Equal numbers of the electrons leave at the top of the plate with the drift with the deposit with the terminal of the battery. With the happening with the capacity is said to be charged with the flow of the charge will continue the voltage across the capacitor equal to the source voltage of the capacity. If the voltage applied with the voltage are equal to the capacitor is said to be charged. The capacitor will remain charged until condition even after the source is removed, so the capacitor will return with a neutral uncharged state. The external path must be provided flow with the charge. The external path may range from the short circuit to zero resistance complicated network. Capacitor returning with the neutral of the uncharged state is said to be the discharging. Although the capacitor is supplied with the energy of the circuit, with the discharging is not classified as the energy source because the capacitor cannot transform. Some of the other form of the energy is electrical energy. It can only be stored with an energy of the sense of the movement of the charge within one direction constitute with electrical current. The current is associated with the capacitor present only when with the capacitor, either with the charge with the discharging for only the time of the movement of the electron. Should be emphasized with the charge flows not between the plates of the capacitor, but only with the electrical circuit. Although with the commonly referred to the current in the capacitor, with the capacitor current of the capacitor is classified either with the fixed or variable circuit letter symbol shown in figure 12.9. C with the fixed capacitor with a non-adjustable value with the variable capacitor has one set of plates that are movable, thereby changing the value of the capacity. Alright, the fixed variable capacitor with the maximum voltage rating specified with the manufacturer voltage across the plates with the capacitor exceed with the maximum rating of the dielectrical with the breakdown with the permit the charge flow between the plates. In terms of charge voltage capacity with the ratio of the charge should be stored in plates on the capacity of the voltage mirrors across the capacity. The capacity is equal to the quantity of the capacity total over the volume of over the voltage constant the terminal. So we first discuss voltage current relationship with the relation with the capacitor with the current with the voltage with the capacitor, time with the rate of the charge of the voltage across, amperage current, amperage of the capacitor, times the capacitance, the time of the direction the direction of the voltage current, the time of the direction of the current, the divided by the direction of the time. Energy stored in the capacitor. Energy stored with the capacitor shown with the energy 1/2 over the capacitor times the voltage squared. Capacitor in series. Capacitor connected in series combined with the resistor. Capacitor's equation is equal to 1 over 1 and C1 plus 1 over C2 plus 1 to Cm. The two capacitors have the shear of the product over the sums. Equations capacitor's equation is equal to C capacitor 1 plus capacitor 1 times capacitor 2 over capacitor 1 plus capacitor 2. Capacitors in parallel, capacitors connected in parallel combined the same in the way as resistor series. Capacitors parallel combined resistor series. Capacitor's equation equals capacitor 1 plus 2 capacitor 2 capacitor at the end. Alright, 12.6 resistor, capacitor, RC, and resistor inductor circuits, RL. RC circuit figure in 12.22 which over the resistor capacitor with the connection here with the switch for the DC voltage source. When switch is closed with the voltage across the capacitor with increases potentially with the rise of the rate over the rise of the one type of the constant. Voltage across the capacitor has charged with 63.3% of the final value, and it depends on the circuit of time constant with the time of the resistor RC with the resistor capacitor expressed in seconds 1 with the time constant of the voltage across the capacitor reached with the 63.3% steady state value. The particular purpose of the steady state value is reached at 5 times the time constant. The value of the resistance seen with the capacitor is symbolized by the R. The equation of voltage across the capacitor, the voltage increase with the degrees of the exponentially. Voltage capacitance time is equal to the voltage frequency time voltage maximum voltage of the capacitance when charged plus voltage in initial voltage across the capacitor times the final voltage of the capacitor. Maximum value of the capacitor times the electric times amperes divided by the time. Initial voltage across the capacitor is 0. and voltage capacity of the total is given in the equation. Voltage capacity of the total is voltage maximum value times 1 times e to the 1 negative 1 initial time over the total. Alright, RL circuits, figure 1224 show the position of the inductor with the connected and with the switch of the DC volt source. When the switch is closed, the inductor is magnified field opposed with any of the change of the current. Therefore, the current flows increase with the exponential of the rate with the increase of the current dependent on the circuit time of the constant with the time constant with the inductance over the resistance expressed in seconds on one type. Time of constant with the current reaches 63.3% of the steady state value, for all particular purposes, the steady state value is reached at 5 times the time constant. General equation with the current through the inductor of current increase with the decreases exponentially. Amperes inductors total equals amperes final plus amperes initial minus amperes final energy or of the initial the negative initial over the total time constant. And then we go from there up, where IF is the maximum value of the current in the inductor, IF over VTR of the current circuit shown in figure 1224. The initial condition is the value of the current in the inductor before the switch is closed. Note the initial condition value may be 0. Alright, 12.7. Alternating current AC circuit analysis. The section introduced with the AC voltage current waveform. The AC circuit analysis. The analyzed AC circuit requires the use of complex number to complex algebra to solve circuits problems. Therefore, you may refer to Chapter 1 Mathematics Review of the complex numbers. Sinusoidal waves, United States commercial generated electrical energy produced form of the periodical alternating voltage waveform and sinusoidal waveform shown in figure 1225. T represents the period of wave at the time of the one complete cycle. The T of the sinusoidal wave is one time one complete cycle. The reciprocal of the period of is frequency f of the wave, which is given in the equation frequency of the unit of hertz, angular frequency in the units of the radians per second. Unit of frequency in hertz. The wave is periodic because it's every t seconds waited for the figure 25 can be expressed mathematically. Note electrical engineers often express the augmented sinusoidal mixed units of the radians per second in favor of the angles of the degrees. However, to add the WT and angle 0, they must be in the same units, where W is equal to 2 times pi to the frequency has the radians per second and the angle of phase expressed in radians. Average values predict waveform either voltage or current is given in equation 1236a. X is the periodic waveform, either voltage average value current is 1 over the total time derivative of t to 0x. Wave xt, the waveform expression of the time of the domain, time of the distance of the time of the period of the waveform. If the waveform is symmetrically with the time axis, if the average value is 0, the equation in 12.6a state the average value equals the area of the under waveform divided by the period. So we have average periodic waveform A over area of the period. Equation 12.6b used the determinant of average value of the pulse, triangular, other similar shaped waves formed by straight lines only. Alright, effective of the RMS, root mean square values. Alternative voltage currently used is required with the knowledge of root mean square value. The root mean voltage resolve the same amount with the heating effect of the load of the DC voltage, the same as the volt value would produce. Hence, the effect is the same in the general equation of calculating root mean square values as follows. Root mean squared values of the voltage is equal to the square root of 1 times the total time and the time 1 to 0 derivatives of the x to the squared time of the time of the distance, time of the time. And then, impedance. Impedance Z is defined with the opposition of the AC current expressed in ohms, the ratio of the total AC voltage of the current over the both areas expressed the phase of the impedance of the complex quantity. Since both magnitude and phase can be expressed with either rectangular polar form, magnitude angle of the rectangular form of the real part, relative of the imaginary part is reactive of the circuit, and analysis of the components are considered ideal for or resistive element R of the either inductance nor capacitance associated with it. Similarly with the inductive of the element with neither resistance nor capacity, or in the capacity of the element has neither resistance nor inductance. In rectangular form of impedance is expressed where R is the resistance value and X is the reactive value. The resistance may either be the inductive or the capacity. Inductive reactance magnitude of the inductance reactance given the expression. Inductance reactancy is equal to WL times 2 times pi to the frequency length. Inductancy reactancy depends on the value of the L, the frequency times constant 2R. 2 pi. Figure 1228 show the RL circuit driven with the AC voltage show the phase diagram impedance expression circuit given in figure 1228 B and C respectively. For inductor voltage lead to the current in 8090 mathematically lead represented the plus J term impedance of the inductor is expressed as follows. To find an equivalent impedance of the circuit, you have the same rule as resistors. This is adding impedance in the series of impedances parallel. You have the reciprocal rule, capacitive reactance, magnitude of capacitant reactance equation. Capacitive reactance is equal to the W capacitant reactance over the 1 times 2 times pi to the frequency capacitancy. Capacity reactance depends on the reciprocal of the capacity frequency constant of 2 times pi. Figures shown in series RC circuit derived driven by AC voltage source phase diagram impedance expression circuit. The preferred capacitor voltage lengths for the carrying 90-degree lag of the 90 is represented by a negative joule or 1 over joule terminating in impedance formula. And impedance of the capacitor expresses impedance capacitor is equal to the joule over the reactance capacity and joule over the weight W capacitance over joule over the 2 times pi to the frequency capacity. Alright, series RLC circuit figure 1230 show for the RL circuit. The total of the impedance of the circuit is given an equation. Impedance is equal to the resistor times the joules of the inductance and minus the joules of the capacity. Magnitude of the inductance if it is of greater than the capacity of reductance. The phasor diagram will have a positive negative shown in figure 1213b. If however the magnitude of the capacity of reactance is greater than the inductive reactance, the phase angle will be negative shown in figure 1230. Parallel RLC circuit reciprocal impedance is known as the admittance represented as symbol Y. Shows RLC equal to total of the impedance circle given in the equation. And the examples and solutions. Alright, complex power. Topic of this section of the product over the voltage of the time is the current of the AC circuit. The DC circuit of the product is great power dissipated by resistance. The AC circuit contains resistors as well as inductors and capacitors. Power is dissipated with the resistance known as real power of the product. Over the voltage current of the reactive of the elements as well as the product of the total voltage current must be considered the unit of power of the watt and the power symbolized by the letter P. The real power dissipated with the circuit due to the resistance in the circuit given when the equation power is equal to voltage root mean squared times the amps root mean squared to the cosine angle or phase angle measured between V and I. The term cosine angle is referred to the power factor since cosine angle is positive of both positive and negative angles. Power factor is referred either as leading or when the current leads the voltage lagging when the current lags voltage. For analyzing customarily we're using the volt reference. Therefore the inductive circuit's power factor lagging. For a capacitive circuit with the power factor is leading. Voltage ampere productive with the reactive of the elements of the circuit known as reactive power is given in the symbol Q. Has units of volt ampere. Reactives volt ampere is reactive. V or bars. The equation reactive power is follows. Total voltage amp value of the circuit is vector addition of the real power of the reactive power. So the quantity of the volts root mean squared to amps root mean squared is sin 0 angle complex power. The S of the AC circuit roll for the resistive reactive elements was given in the S is equal to the power plus or minus the joules of the reactive power. And the units of the volt ampere, the representative of the complex number of the phase angle, the either the positive and negative depending on whether the circuit is capacitive and inductive respectively, as shown in figure 1235. The power triangle reactive of the reactivity of the positive and capacitive load, the negative and inductive loads. And then it goes into some more power. Resonance when resistor and inductors, capacitors are connected in the frequency with the inductance and the equals capacity with the frequency of circuit is said to be resonance. Frequency is called the resonant frequency. For frequency is zero impedance is the circuit that is minimum and equal to the resonance resonance of the current with the maximum of the voltage drop across the inductance and the capacitance are maximum. The frequency of the resonancy of the capacitance is greater than the inductancy. Frequency above resonancy, the inductor is greater than the capacitance. Resonant frequencies F depends on the value of the inductance and capacity as given in the equation. Resonancy occur with the inductive resonancy equal to the capacity of the inductance, where WO is radians per second equal to 2 times the frequency of the hertz, 2 times pi to the frequency of hertz equal to 1 over the square root of the inductance and capacity. Then the radians per second is equal to 1 over the radians per second times the capacity impedance in circuit is equal to Z is equal to impedance is equal to resistance. Figure merit compare resonance circuit known if the Q factor resonance is equal to radians per second over the resistance over the 1 times the resonance per radians per circuit over the capacitance and resonancy. Note when analyzing resonance circuits similar to the reactivity represent the quality factors don't show over the reactive power. Figure 12-37 show the current series of the circuit value of the frequency of the ratio of the resonant frequency of the quality known as bandwidth. Bandwidth of the equation of bandwidth of the radio per seconds over the reactivity of the resistance over the inductance in radians and seconds. Bandwidth is equal to the radians over the 2 times pi of the length of the inductance over the times the hertz. For figure 12-38 with the parallel LR is equal to the frequency of the inductance is equal to the capacitance known as the resonance frequency is given in 1248 with the circuit voltage maximum resonancy and the quality factor. So we have a reactive with the radians per second of resistance times the resistance capacity area is equal to the resistance over the radians over the inductance over the equal to L. And then we go over to more solutions. Alright, your ideal transformer, section 12.4 is stated with the current carrying of the conductor of the magnetic field with associated with the current AC strength of the magnetic field with the constantly increasing decreasing likewise with the change of the magnetic field that exists with the conductor. AC voltage induced in it. Current exists with the conductor provided with the closed path exists. The magnetic field increases by winding the conductor in form of a coil, creating the passive of the element with itself with the inductance. 2 coils placed in the change of the magnetic field with the inducing voltage, and the other 2 coils connecting with the mutual induction. Mutual induction between 2 coils is directly proportional to the number of the magnetic lines force of the common both coil. The closer the coils are with one over the greater mutual inductancy. Mutual inductance increased further. Both coils beyond one wound common iron core shown in figure 1240. Coils are separated. Mutual inductance reduced. Circuit elements with the principal mutual inductance transformer. The review of the section of the ideal transformer that have no loss iron core transformer. The power audio systems currently automatically ideal for the ideal transformer. The reflected dependency current ratio, voltage volume rate, voltage ratio, and quickly and easily calculated terms and number of the terms primary and secondary coil number 1, number 2 respectively. Formulate figure 1241 show the schematic of the ideal transformer equation of the device is equal to A represents the ratio of the number n to 1 and n is A represents n over 2. Transformer U the set voltage is up down in various points. Represents the number the N1 to true voltage primary over voltage secondary equals amperes secondary over amperes primary. Then it shows the transformer current. Note the voltage is directly proportional to the term of the ratio, current reversely proportional over the terms of the ratio, hence ideal transformer of the power of the primary side is equal to the power of the secondary side. Alright, polyphase systems. Polyphase systems used for the generation and distribution of large quantity of power. Some of the advantages of these system and induction motors, the inherent storing torque because of the voltage are out of phase. Total power is constant. Systems are more efficient. Fixed distance of the line and loss of the less. Although polyphase systems may have a number of voltages that not in phase, most polyphase systems are three-phase. Three-phase is noted as 3 with a line through it. Motors are smaller. Single-phase motors are same horsepower, operate with a vibration, have constant torque. With figure 1245 show the waveforms produced. A three-phase generator. Waveforms are 120 degrees out of phase with another. Three-phase distribution systems are often used in business and industry. A balanced YY connected system neutral current is 0. However, the practical YY systems are not balanced. Therefore, the neutral current is not 0. Shows different YY combinations. Figure 1246 show the 3 single windings. The windings may be connected by a Y connection, also called the star connection, shown in figure 1246, or a delta connection, as shown in figure 1246. C. Y configuration, common concentration breakout used if it is referred to neutral. The delta configuration, there is no neutral. Generators are not connected in a delta configuration, but transformer windings are from a Y condition. Connections generators may be specified with line to line, line to neutral. From delta connection, voltages are measured only line to line. For Y connection, the line current equals corresponding phase current given in the equation. Amperes inductance equal to inductance phase over the voltage phases and over the impedance phase. Line-to-line phase voltage Y connection at 30 degrees phase out relationship to voltage. The absolute voltage inductance is equal to the square root of 3 times the voltage phase absolute. Analyze delta configuration similar with the Y connection equation involving the voltage current of the Y is same mathematical form. Counterpart current voltage of the delta connection line to line phase voltage equal to the connection voltage inductance is equal to voltage phase times equal to the amps phase times the impedance phase. Line to phase currents are delta currents connection at 30 degrees out phase relationship between the magnitudes expresses amperage inductance is equal to the square root of 3 times the amperage phase. Alright, 12.8 operational amplifiers. Operational amplifiers, op-amp. When circuits are similar to shown figure 1248 with a high gain and a directed coupler amplifier, open loop gain with the AOL, several hundred thousand differential input voltages, the differential voltage equal to voltage 1 minus voltage 2, small voltage occur order in microvolts derives an amplifier output voltage VO, the different input voltage ED times open loop gain. So you have output voltage equal to open loop gain each times the differential input equal to output open loop gain times voltage 1 minus voltage 2, where voltage 1 and voltage measure the non-inverting input and plus sign terminal of the operational amplifier respect to the ground. Voltage 2 with the voltage measure the inverting input terminal at respect to the ground. For the operational amplifier's maximum output voltage swing, usually 1 or 2 volts less than the power supply voltage, which are typically set with a plus or minus 15 volts. Therefore, the maximum output voltage swing would be plus or minus 13 volts. The difference between the input voltage is referred to as differential signal. For most application, operational amps are external resistors connected between the operational terminals and the operational and negative terminals. The type of the circuit for the connection for the negative feedback, with the advantage of the negative feedback circuit, the performance is expressed in terms of the operational closed loop gain, which depends only on the external circuit by the adding in the negative feedback circuit. The designers ignore the change of the amperage out operational open loop open amp to open amp as long as the amp open loop is at least 10 times larger than the amp closed loop. The review considers circuits with the characteristics ideal for the operational amp summarized below with the negative feedback. Ideal op-amp characteristic: open loop gain is infinite with the differential input voltage is 0. The current drawn by either plus or negative input terminal is negligible, and the output impedance of the operational amp is negligible. Inverting amplifiers. Figure 1249 shows one of the most commonly used amplifiers closed loop gain as with the value of the resonant frequency and resonant initial and resonant initial according equation with the minus signs indicating the output of the input voltage is at 180 degrees out of phase. Therefore, the circuit head shown with a negative gain in the operational amp circuit with the 1249 can amplify AC or DC signals. Operational amplifiers are most often used with negative feedback where the part of output signal is returned to input. Characteristic of inverting amplifier: the input resistance of the circuit is equal to the resistance or initial magnitude of the closed loop gain is the ratio of the resistance frequency of the initial output voltage of the negative of the input signal of the voltage of the inverting negative signal of the virtual ground of the electrical is out of microvolts. Or a non-inverting amplifier, the operational amplifier circuit, the 1251 input voltage applied with the non-inverting positive terminal. Hence, circuit is referred to as the non-inverting amplifier. The gain of the circuit given them as amp closed loop is equal to 1 times the resistant frequency over the ramp's resistant initial equal to ramp resistant frequency plus ramp initial over the resistant initial. Output signal of non-inverting amplifier in phase of the input signal. Here, non-inverting amplifier input resistance circuit is shown as the input voltage over the infinite magnitude closed loop gain plus 1 output voltage in the phase of the input signal. Inverting sum of the amplifier operational amp circuit figure in 1252. The input voltage applied with the inverting and negative in terminal. The circuit is referred to inverting sum amplifier output voltage circuit is given in the equation. And Alright, 12.9, electric magnetic fields. The section reviews some of the fundamental principles of electrical magnetic fields. Electric fields introduce the concept of like charges repel and unlike charges attract. Charles D. Combs, 1736-1806, first mentioned for the attraction repulsions. Cited that law of the governs of the charge object size is much and smaller the distance between them, and the concept of known as the point of charge. Combs express this as magnitude of force acts on 1 over the 4 pi over the unknown permittive constant times Q1 and Q2. There's the charge of the objects over the distance of the charge objects. Our farad per meter is 8.854 to the 10 to the 12 coulombs squared Newton over Newton to the meter squared farad per meter. Note the force of farad is the force is vertically quantity with the direction of the force determine the direction of the positive point of charge move with wind and release. If the multiple point charge point beyond the object vertical addition may be you to find the resultant force of the object. In vicinity of the end of the point of charge there is an electrical field E with the units of E with the newtons per coulomb, the volts per meter. Lines of the force constitute the electrical field of flux. Direction of electrical flux convention with the direction of the positive charges would move with the release in electrical field. 1254 shows how to visualize the electrical field between positive and negative charge. The magnitude of the electrical field and intensity given in an equation. Alright, magnetic fields that exist with the space around a magnet. Lines of the magnetic flux shown with the magnitude of the direction of the north and south. With the pole shown in figure 1256. The total amount of the magnetic flux measured in Webers, represented with the symbol poker. Magnetic flux density B Weber per meter or Tesla is calculated dividing magnetic flux perpendicular to the given equation. So you have a Weber is equal to a Weber is equal to over the area, the magnitude of the string over the field of the H is measured in amperes per unit or H, which was was it Henry's? Um, 1210 DC motors. Motor is a machine that converts electrical energy with the mechanical energy with the DC and AC electric motors. All motors interaction, electrical magnetism, the three basic processes occur. One current flowing in the conductor creates a magnetic field around the conductor. Two, the current carrying conductor is external magnetic field with the force of the conductor move the generator motor cork through the conductor move the magnetic field has voltage induced into the motor, and all three these interactors occur. 1258 illustrates the first effect of the current carrying conductor permanent magnet field with the current carrying conductor is moving at right angles. Permanent magnet field in this figure the current flows from the conductor into the edge of the magnet field with the clockwise direction around the conductor, given the right hand rule with the thumb on the right and points with the direction of the current flow with the finger curls within the conductor. In the direction of magnetic field, the magnetic field of the current carrying conductor figure 1258 interacts with the permanent magnetic field shown with the due to the interaction magnetic field above and below of the conductor and decreases respectively the strength of the magnetic field above the conductor is in the downward direction, and the force generates more torque as the conductor moving the magnetic field with the third process applies. The voltage will induct the conductor's amount output of the input voltage of the motor. In example, the magnetic field will produce the permanent magnet. One method of producing magnetic field. However, the magnetic field can also be generated by current carrying conductors and field windings. The basic structure of electrical motor indicators two major components: a stator and a rotor. They were separated with the air gap. The stator does not move in the stationary part of normally the motor's outer frame. Conductor reproduces the magnetic field referred to the field windings that usually wired within the stator. The rotor is is part of the motor with the freedom to move the rotating part of the motor over the normally of the motor in inner part of the conductor's wires, and this part known as the armature shown in figure 1259. In advance of the DC motor ability of the control shaft speed controlling input voltage, DC motors identified with the way of the field winding connected to the DC motor field winding is connecting parallel with the armature identified with the shunt motor field winding is connected to the series of the armature motor identified with the series motor. Third type of the DC motor is compounded with motor of the motor implies both shunt and series field windings. Fourth type of the DC motor has separate excited field, figure 720 1260. Field winding connection with the DC motor, losses of the motor electrical power input, electrical power armatures. Loss of power input equals loss of power input equals loss of power output, where power input is equal to voltage A times amp voltage. Voltage induced the armature amp, the armature current of the mechanical output power is given. Power output times the generated torque in Newton powers times angular of the velocity and radius per second, and voltage amp induced back and referred to back to the EM forces of the counter EMF, and to the conductor move the magnetic field in terms of motor parameters expressed, and then where K is dependent on the motor of the design, magnetic flux per pole times the speed of the armature in volts. Motor constant of the K is given as P in the number of the poles, Z is the total number of the conductor of the armature is winding, A is the number of parallel class armature windings for separate excited DC motor. Electrical power motors is power time is equal to voltage, input voltage to the motor, also referred to terminal voltage, and ampere current, armature current. An equivalation circuit of the DC circuit motor, excited field winding, movable current carrying conductor called the armature shown in figure 1261. Resistance A, resistant amp armature, equivalent armature resistance, inductor armature, and amperage armature current. Armature current can be expressed as armature current times voltage total minus voltage ampere armature over the resistance armature with the armature inductance considered negligible. And it goes into examples, solutions. We're on to 1211. Summary: electrical energy engineering, similar to the other engineering, covers a vast amount of the material. The objective of this chapter will be introduced, read some of the underlying principles that are helpful in solving the circuit problems. Circuits are composed of sources of load. Most of the chapters analyze load with composed of the passive elements, resistor, inductor, capacitors. But the last section does not introduce circuits that include integrated circuits in the operation. An amplifier resistor dissipates energy, while the inductor capacitor can store energy, magnetic, electrical field. Respectively, the concept of the charge of the current, voltage, power, and energy were introduced, as shown that they are related to the current and time and the rate of charge of the voltage. Measuring energy per unit charge and power is the rate of energy transferred. Ohm laws and Kirchhoff's voltage current laws were used to analyze circuits as well as to show how the same elements in series parallel combine to determine the equivalent value. Some circuits are best analyzed either with a Thevenin or Norton equivalent circuit of both circuits of the multiple sources. May need to solve it differently, such as by using the loop analysis. The circuit analysis techniques applied with the resistive circuits are induced. Resistor inductors and or capacitors have AC sinusoidal input of the analyzer. The first determining inductive capacitance, reacting with the inductor capacitance element, and applying previously mentioned circuit analysis techniques. Resistor inductor and resistor capacitor circuits driven with the DC input voltage sources were analyzed. These circuits have the transit output response either with exponential rise or exponential decay. Business and industry often receive the power of three-phase motor power sources loading connected either with a wire delta transformer are usually used to step up, step down voltage. For ideal transformers, power is on the secondary side, but the transformer is equal to power over the primary side. Therefore, the voltage is stepped down, current is to step up, and current is stepped up, and vice versa. Operational amplifiers, high gain DC coupled to integrated circuits are the basic building block in the Magnetism system. The chapter introduces showing how three basic amp circuits of the inverting, non-inverting, and summing amplifiers and analyze. Voltage gain of these circuits is set by a resistor external with the operational amplifier. The chapter ended with a short introduction to electrical and magnetic fields. Chapter 13, Thermodynamics.